All right, let's take a look at interpreting p-values. And in order to interpret p-values, we have to kind of get in some data here. So it's claimed that the average body temperature is 98.6 degrees. This is known as our null hypothesis, which I have written right here. All right, this is some kind of claim that we know is true. But I've been really collecting a lot of data lately from some random samples, and I've been finding that a lot of students are actually below 98.6 degrees. In this sample of 16 individuals, I actually found that the average was 98.1 degrees. And so my alternate hypothesis is going to be this. I think based on the data I collected, I can't say it's 98.1 degrees, but I think that the average body temperature is less than 98.6 degrees. So what we're going to look at is like how strong is the evidence here to say that, what, you're right. I think it is less than 98.6 degrees. Now, we can't say it's 98.1 because this was just a random sample. But do we have enough strength in our data to say, what, the null hypothesis, I don't think that really holds anymore. I think it's less than 98.6 degrees based on the data I've calculated. All right, so in order to do this, we're going to look at z-scores, and directly related to z-scores are p-values. Right, so let's jump into a normal distribution. And here I have a z-score of 0, which is 0 standard deviations, right? And I have the area shaded to the left of that, which is about 50%. Obviously, this isn't all the way in the tail, but if I brought this closer and closer to the tail, this would get closer and closer to 50%. All right. Each one of these tick marks represents a z-score, which is simply the number of standard deviations from the mean. So for example, if my data set was 1 standard deviation away from the mean, right around here, there we go. I could say that this shaded region is now about 17%. All right. If I was 2 standard deviations away in the negative, all right, I'm about 0.025. And this would be for a test that is a less than test. So z-scores represent how many standard deviations you are from the mean. The p-value represents this blue region, or purple, whatever. And that is the area in the curve. All right. And I could also bring this over to the other side if I wanted to. All right, move this guy. And I could put it in the other tail if I wanted to as well. Let's look at the data that I have collected from our pretend study on body temperatures. So we know that the null hypothesis is 98.6 degrees. That's what's claimed to be true. But in my sample, I found, if you go back to that spreadsheet, I found that my sample was 98.1 degrees. The standard deviation was 0.584, and the sample size we used was 16. All right, and this was, since our mean was less than our null hypothesis, we're thinking that it's going to be less than, we think that the body temperature has actually decreased. It's not 98.6 degrees anymore. All right, when you jump down into here in the results, you see a z-score of negative 3.42. What that means is that the data we found, the average, that average of 98.1 degrees, was actually about negative 3.6 standard deviations below the mean. So right about there. All right. Now, this was a left-tailed test. Okay, so that means that this other piece here, I don't know if I can grab this. There we go. It means that we want to find the area to the left of negative 3.649. All right. There we go. So you can't see it here because this shaded region is so small. All right. Remember that shaded region represents the p-value. Our p-value is 0.0003, which is tiny. We usually compare this value to something like 0.05, which is known as your level of significance. All right. Since my p-value is so much smaller than 0.05, we have very convincing data that the average body temperature is indeed less than 98.6 degrees. All right. This p-value of 0.0003 represents the likelihood of obtaining the statistics we got by random, okay, which means that there's a very slim chance that what we generated was random, and there actually is some truth to the numbers. All right, so that's how you interpret p-values. The lower the value, the more convincing your data is to say, you know what we found is very unlikely to have happened by chance. There actually is some truth to what we're finding. And a lot of times we compare this value to 0.05. That's like the hinge point to say, hey, is it convincing or is it not? And we use a level of significance of 0.05 or 5% as kind of like that hinge point. All right.